All right, so you should have filled out already this table with your own values. And one of the questions was, what are the new coordinates for the vertex in each transformation? And so the new coordinates for the vertex in here, we see that when x is 3, y is 0, and that is the lowest point. Anything after that, then y is just going to continue to increase again. So one of the conclusions that you may draw is when we subtract 3 from, or any value really, from x before you square it, that means that it's inside the parentheses and the exponent's on the outside, then that's going to become the value for y, except that it'll be its absolute value. So it's not going to be negative 3, it's going to be a 3, positive 3, 0. That's going to be your vertex. Now I want to do the other type of transformation when we add 2 instead of subtracting a value. So go ahead and fill out the table here. I'm going to give you a couple of minutes to do that. And then I'll come back and we'll talk about the results to see what happens to our vertex when we add 2 to x before we square it. Okay, so these are the values. I went ahead and filled it out. And one of the things that I noticed about my vertex, well, first let me go ahead and graph it. I'm going to add 2 to x. Is I noticed that my entire parabola moved to the left. So when we're subtracting a value, your parabola is going to move to the right. And when you're adding a value, your parabola is going to move to the left. So that's the first thing I noticed. I'm going to go ahead and give you the parent function here. It's x squared. And since we're going to talk about the differences between these two, I'm going to go ahead and put both of them in the graph. So my parent function is in purple. The one that I am subtracting 3 is in blue. And the one that I'm adding 2 is in red. And one of the things that I noticed is that my vertex for the red parabola changed. And now is negative 2, 0. So if I'm adding a number, then the opposite is going to become the vertex. And if I'm subtracting, the opposite is going to become the vertex as well. Now let's go ahead and move on, because the whole point of this is for you to be able to do these translations and transformations on your own and write the formula for those transformations. Go ahead and pause the video and try to give these a go and see if you know what that formula might look like after these transformations, A through E. This is not a multiple choice question. There's actually A, B, C, D, E, 5 problems. Okay, so before we do this, I'm going to quickly summarize what I have learned. These are notes for me that are going to be available for you as well, and you may be taking them right now. And if you're not, the empty sort of outline for these notes is available on the website for our class. But I know that if I'm going to move my graph to the right, then I have to subtract within the parentheses. I learned that from the last transformations that we saw. And if we're going to move the parabola, the graph, to the left, then I need to add inside the parentheses before I square it. Now, if we're going to move up or down, then I should do whatever addition and subtraction outside the parentheses. So this happens after you square it. So if I move up, I'm going to add, and if I move down, I'm going to subtract. So those are the translations. Those are your transformations. Then we also learned about dilations. And the dilations can either be vertical stretches or they can be vertical shrinks. They can also be horizontal, and we'll talk about that a little bit later, but so far you only know about stretches and vertical shrinks. We know that it's going to be a vertical stretch when your coefficient is larger than 1, and it's going to be a vertical shrink if the coefficient is larger than 1, a vertical stretch if the coefficient is less than 1. So I have some problems in here that you're going to try to do. So let's go ahead and try to tackle some of them right now. I am going to do letter D. And I'm trying to move this graph 4 units to the left. I'm going to move to the left. That means I have to do the addition within the parentheses. That's what that formula would look like. Then I'm going to do problem E. You can pause and slow down this video if it's going too fast. I'm going to scale this by a factor of 1/3, and that's what it would look like. So writing the formula for these gets to be rather quickly once you know sort of the tricks and shortcuts that tell you what happens. And I have a graph, and I want to be able to write the formula for that. One of the things that I notice is that this vertex is -6, 0. So I know it has moved from that 0, 0 to a -6 to the left. So that means I have to add a 6 inside the parentheses. I have this other graph where I notice that it has reflected on the x-axis. And so we know from past lessons that when a graph reflects on the x-axis, that means that the coefficient has changed sign. So if it was a positive coefficient, it's now a negative coefficient. So my parent function being x squared, I'm going to change that to a -x squared. Now the other thing that you really need to check when you're looking to write a formula for a transformation that occurred on a parent function is your points. Even though I know that this has reflected, I want to be sure that no other transformation has taken place. So what I'm doing right now is I'm gathering some points. The parabola, the parent function, the x equals 1 was sitting at y equals 1. And now when x equals 1 with our new graph, y equals -2. So what I'm trying to do is I'm trying to figure out how we got from a 1 to a -2. What is the rate of change there? And of course we know that the rate of change in there would be a ×2. So what I'm going to do is I'm going to change this to a -2 coefficient, and then that is your final formula. Let's go ahead and try this other one. Why don't you go ahead and try to pause the video and do this on your own. In our first transformation, we are using the x squared as our parent function. We're going 2 units to the left and 4 units down. So if I'm going to the left, I know that I have to add within the parentheses before I square it. And if I'm going down, I know I have to, after I square it, subtract 4. Went ahead and copied my little cheat sheet here so that it's a lot easier to write these. But I'm going to add 2, then square it, and then I'm going to subtract 4. For the problem B, we have to translate it and go 2.5 units to the right, which means I have to subtract 2.5 inside the parentheses and add 1 up. And so my vertex would change to 2.5 and 1 up. The next problem, I have to use a scale factor of 1/2 and then translate it 3 units to the right. So I'm going to put that 1/2 as my coefficient. And then because I'm going to move to the right, I have to put parentheses before I square it and subtract 3. The real secret with all of these is just practice, practice, practice. You'll get better with the more that you do. And our last transformation, it asks us to go 5 units to the right. So that means I'm going to have to subtract inside the parentheses 5. And a vertical scaling by reflecting across the x-axis with a vertical scale factor of -2. That means my coefficient is going to be a -2. So it's going to flip it upside down or mirror it across the x-axis. And then it's going to be narrower. I have these other 2 graphs, and I am being asked to write a formula for the following graphs. So you take pretty much a similar approach. You start with your parent function, which is x squared. Then you look at that vertex and see where it is. And you notice it has moved 3 spaces to the right, so I'm going to subtract 3 before I square it, And then you also notice it has gone up. I would say 3 units up. So then you want to add 3. For any of these, you can go back and pause it before I give you the answer and try to do them yourself. I'm going to do the graph on the right now. The first thing you may notice is that it's been reflected across the x-axis, so you know that your coefficient is going to be negative. And then you look at that vertex and you notice that it has moved from 0, 4 spaces to the left. And because it's to the left, that means that you have to add 4 spaces, or however many spaces it moved, before you square it, so it has to be inside the parentheses.